Okay, number 10, we want to use the intermediate value theorem to show that the polynomial has a 0 in the given interval. Now, I think I still have the textbook up. I always like to show the definition of the intermediate value theorem. It's very, I think it's very simple once you understand it. But understanding it is part of the challenge. So there's a lot of things covered here. So here's the intermediate value theorem. Here's the definition. F is some polynomial. We have an A less than B. If f of A and f of B are opposite signs, there's at least one 0 between A and B. Okay, so what does that mean in English? Okay, we have two numbers. Let's say 3 and 5. One of them has to be less than the other one. It just means that they're not the same number. So one number is smaller, one number is bigger. So they're showing you here on the x-axis. Here's A, here's B over here. Okay, we're going to plug those two numbers into your equation. So replacing x, we have f of x right here. Replace them with those two numbers. So if I plug in, let's say this was 3, I would get a y value. So let's say that y value came out negative. It's below the x-axis. And then when I plugged in b, it gave me something positive above the x-axis. If you get that as a scenario, that means at some point your graph had to cross the x-axis to go from negative to positive. Okay, because one sign came out negative, one sign came out positive. That's what that means, opposite signs. So it had to cross at some point if it went from negative to positive. That means there has to be a 0 in between them. That's what this is saying. That's it. So not easy to read, but it's really simple once you have an understanding. So what we're going to be doing is plugging in these two values, -3 and 0. And once we plug them in, we want to see, are the signs the same or different? Now we can do this really quick with a calculator, but I like doing it with synthetic division by hand to help you guys out. Also, this is a part of synthetic division that we have not seen yet on this problem. So I also want to do it that way as well. And we will verify with the calculator. So we have 15x to the 4th, and then minus 5x squared, and then plus 9x, and then minus 1. And the numbers we're going to be checking are -3 to 0. Okay, with synthetic division, you have to have all your terms in descending order. So we have x to the 4th. I am missing x to the 3rd. So I need something to replace that. I have a 2, 1, 0. So I got 4, no 3, 2, 1, 0. That missing x to the 3rd is very important. So what we're going to do, if I'm doing synthetic, I'm going to list my coefficients. So I'm going to list 15. I don't have an x to the 3rd, so I have to put a 0 as a placeholder. That's important that you get that. And then we have -5, and then we have +9, and then we have -1. Okay, so I'm going to do -3 first. Bring down 15 times -3, -45. Add to 0, -45. Times -3 will give us a +135. Combined, they get a +130. Times -3 will give me a -390. And when we add this gives me a -381. And then times -3, it's getting really big. Let me just round. I'm going to estimate 380. And that would give me 900 times 3 times 80 is 24. So 9 and 2 is 11. So 1,140, 1,143. And that would be positive 1,143. That would be positive, subtract 1, 1,142. what we get is this is positive. That's what we need. That sign is positive. So this one gives me a positive value. I'm going to do the same thing with 0. 15, 0, -5, 9, and -1. Bring down the 15 times 0 is 0. Add, we get 0. Times 0 is 0. Add, we get -5. Times 0 is 0. Add, we get 9. And then times 0 is 0. And add, and we get -1. Okay, so the end result, these are the numbers that we're focusing on. The end result is positive. This end result is negative. These have opposite signs. So by the intermediate value theorem, we can tell that at some point between -3 and 0, this graph will cross the line. Now, I also want to graph it. I want to show the results in the graphing calculator. Just speeds up the process a lot faster. I'm going to go to y equal. I'm going to clear out what we have, and I'm going to type the 15x raised to the 4th minus 5x raised to the 2nd, and then plus 9x and minus 1. All right, I don't actually have to graph it. I'm just going to do second graph to see the table. And we're going to focus on the two numbers, -3 and 0. So I have to arrow up. So here's -3. We can see we get 1142, what we computed by hand. And at 0, we get -1. And so that's what they want here. When I plug in -3, we got 1142. Just verifies what we got. When we plug in 0, we got -1. And then, according to the intermediate value theorem, do we have a 0? Yes. Now, if you do intermediate value theorem, and let's say this one comes out positive and this one comes out positive, then we cannot tell. Okay, the graph of the function could do something like this. So let's say that this is one of my numbers. Let's just call it 2. Let's say that this is 5. Okay, let's say my graph starts up here, and then it dips down and it comes back up. So when I'm at 5, I get a positive answer and I get a positive answer. Now, if we look at the graph, we can see it goes below, but just by doing intermediate value theorem, we would not be able to tell because both the signs are the same. The only way we know if there's a 0 is if the signs are different. So if the signs came out the same, either both positive or both negative, then the intermediate value theorem would be inconclusive, okay? Because it could very well go above and then back down, and there could be a 0, but we just don't know by the intermediate value theorem. However, if the signs are different, like in our case, then we clearly can tell that there's a 0 going from positive to negative.